Good morning, afternoon, or evening, everyone. On behalf of the Monitoring, Evaluation, and Learning Division at the USAID Bureau for Food Security, I would like to welcome you to the latest installment in our Feed the Future MEL webinar series. Today we are going to be focusing on Feed the Future's agrometeorological context indicators, what they are, and how to use them. My name is Julie McCarty, and I'm a Knowledge Management and Learning Specialist at USAID BFS, and I will be your host and facilitator today. Before we get started with the presentation, I would just like to orient you to a few things in the webinar room today. Your main way of communicating with us is the chat box, and I can see that lots of you are using that already, which is great. We love for our webinars to be interactive, and so we encourage you to introduce yourself and to ask your questions at any time throughout the webinar. We'll answer some of the questions in the chat box along the way, and then pause after the presentations for additional verbal Q&A. If you would like to download a copy of today's slides, you can access them on the left of your screen in the little download box. And there are also some recommended links on the top left of your screen, including a link to the Feed the Future Indicator Handbook and a link to the kind of landing post in our awesome Earth Observations AgriLinks series. We've been doing a whole series of blog posts, events, and resource postings on AgriLinks over the past month of May, and so I encourage you to check that out. Also, we are recording this webinar, and we'll post the recording on AgriLinks later today, and we'll post a transcript of the recording in about a week or so. As I previously mentioned, today's webinar is part of a series. We did a whole bunch of MEL webinars last year, and here is a set of links to all of the past webinars. You can find them all on the agrolinks.org website. We encourage you, if you need a review on any specific indicators, especially some of the new Feed the Future indicators that came out recently, to go back and to watch the recordings or to browse through the transcripts or the slides. It's a handy resource, I think, for the Feed the Future community. All right. Next up, I am going to introduce our USAID lead on this topic, Kiersten Johnson, who will then introduce our other speakers and provide an introduction. So our first speaker will be Kiersten Johnson, who is currently serving as a Monitoring and Evaluation Technical Advisor in the USAID Bureau for Food Security in our Monitoring, Evaluation, and Learning Division, focusing on the U.S. government's Feed the Future initiative. And she's an international population and health demographer with 20 years of experience in lots of data analyses, including in-depth analyses of demographic and health surveys and service provision assessment data for USA Global Health and such. And she's been a really excellent lead on our Earth Observations Month on AgriLinks. So I'm going to pass the microphone over to Kiersten, and we'll get rolling with the content.
Great. Thanks very much for such a nice introduction, Julie. I'd like to welcome everybody, and thank you all for joining us this morning. We are very excited to introduce and to welcome Brian Barker and Ritvik Sahajpal as the guest presenters. They are researchers at the University of Maryland's Department of Geographic Sciences, and they're both part of the NASA Harvest Consortium. NASA Harvest, it's a new multidisciplinary program that's funded by NASA and led by the University of Maryland. It's quite a large consortium. And the objective of NASA Harvest is to enhance the use of satellite data for decision-making related to food security and agriculture, both domestically and globally. So NASA Harvest has been really instrumental in supporting USAID's Bureau for Food Security and Feed the Future to really start integrating Earth observations data and insights into our work. And today's presentation is just one example of the way in which our colleagues at University of Maryland and NASA Harvest have really been helping us improve our work with these new data and new indicators. So thanks to both of them, and you'll be hearing from both of them later. So what is the objective of this webinar? We're very excited to introduce these new agrometeorological context indicators. These will be helpful to allow us to interpret agriculture-related outcomes, specifically yield, but potentially other agriculture-related outcomes as well, through the lens of rainfall, greenness, and temperature. Let's see. So that's the first objective, is to really just get people used to looking at these indicators, hearing about them, understanding what they mean. We'll talk a little bit about how the indicators will be calculated, and also then discuss how they can be used to interpret agricultural measures of interest. The new context indicators, they basically reflect, as I mentioned before, rainfall, greenness, and temperature. They can be found in your Feed the Future indicator handbook on the indicated pages there. I think we have, yeah, the Feed the Future indicator handbook. There's a link to it in your web links panel there, the second in the row. So if you need to go and have a look there, you can do that. So the first one reflects an average Standard Precipitation Index score during the main growing season. Feed the Future Context Indicator 13 reflects the average deviation from a 10-year average NDVI, which is the Normalized Difference Vegetation Index, which is effectively just telling you how green the vegetation on the ground is. And then temperature is articulated in this indicator just in terms of the total number of heat stress days above 30 degrees Celsius during the main growing season. So what is the rationale for adding these indicators? So people who've been working with Feed the Future since its inception will notice that we didn't have these earlier in our work. So why would we add them now? Especially for monitoring and evaluation, it's really important to understand the context in which the outcomes that we are holding ourselves accountable for are occurring or not occurring. So in places where rain-fed agriculture is predominant, the weather is really a key factor in determining yields, for example, which we monitor annually. It can also be a key factor in determining some other practices, like how much area to plant or how much inputs like fertilizer or seeds to purchase. So without having a sense of weather-related variables, like temperature, like rainfall, from year to year, it's not possible to really interpret trends and performance in indicators like yield. So was it El Nino that negatively impacted farmers' production in the zone of influence this year, or were our programs slow to get started? Was it a bumper crop for everybody this year because of perfect weather, or were our programs really just especially effective in the zone of influence? So without understanding really what the weather was like in very simple terms, it's very difficult to give an appropriate interpretation of the key indicators that we monitor as part of our programming. And so I think one last thing I wanted to mention before I turn it over to Brian, I wanted to thank Jim Verdon from USAID's Food for Peace FuseNet program, Moffitt Ngugi, who is on the call right now, who's in Liberia, but was previously on our in the Bureau for Food Security, as well as Anna Brennis and Babawima Kegninawat. All of them were instrumental in helping to kind of determine which of these, which variables that we would include in our new context indicators, and helped define them, write the indicator handbook definition. So I just wanted to thank them for their help from the very beginning. All right, from there, go ahead, Brian.
Thank you very much. Good day, everyone. Looking at rainfall, rainfall is definitely one of the most important factors for crop development and final productivity, especially for rain-fed agriculture. Too little or too much rainfall is also often associated with lower yields, and the timing of rainfall is also important. It's critical during the initial sowing and early crop establishment in order to have good soil moisture levels to continue to have the crop grow. In addition, looking at consistency of rainfall is also important across the entire growing season. You don't need just in the beginning. You also need some throughout the entire time period in order to have the crop continue to grow and be healthy in order to develop the proper yields that people need to eat. In this chart, we're examining the average Standard Precipitation Index score, and as we move across the growing season, this happens to be for maize in the upper west region of Ghana. And if you look at the calendar, we can see on the chart we've noted different parts of the calendar for maize. Planting, green up was when the crop emerges in the ground and starts greening up and getting that healthy green vegetation. And then senescence, when the crop starts devoting most of its resources to developing the actual seeds and pollen. And then actually at that point you start seeing the crop start to wilt in some cases. And then all the way down to the end, at the very end of harvest on the far right in October. Now here in this particular season, we can sort of see how the season is going. Initially, you can see we had quite a bit of rainfall. Actually, it's very extremely wet to very wet and then moderately wet as we continue along the season. And then as you get into the main growing period, we're seeing that it's gotten a little bit drier down to moderately dry period right there, and then actually rebounds later in the season. Okay, next slide. Okay, now this is the Normalized Differential Vegetation Index, or NDVI, and basically what it measures is greenness of a plant, how much photosynthesis activity a plant is currently doing. Now, a high with NDVI value will basically say this is a very healthy plant or growing area, and then a very low NDVI, all the way down to the bottom, indicates bare earth or dead plants. Now, in this case, we are examining departure from the 10-year average NDVI, and so if 0 is the average or the normal, departure above is a good thing, it's showing a very healthy area, and below is actually showing a very negative area. So in this case, we can see as it progresses across the calendar, early in the season, we're seeing quite healthy growth, and which means quite a good development of the crop itself. And then as it gets closer to senescence, we're seeing normal NDVI, which is showing that the season is progressing quite normally at that point. Okay, and the main source of this data, as a side note, is the NASA NDVI MODIS instrument, which comes from the Terra and Aqua satellites. Okay, next slide, please. Okay, this is temperature. Temperature, this is an indicator measuring total number of heat stress days over the course of a growing season. Temperatures over 30 degrees Celsius during the main growing season can have a negative impact on plants. Higher temperatures can have negative impacts in the sense that it makes the plant to go through evapotranspiration and give off moisture more than it would like, and then that can once again stress the plant, especially if the soil levels don't have a lot of moisture in it. The plant will be stressed and won't be able to continue developing. Additionally, it will raise the temperature of the soil, which is not good for some plants, and also high temperatures, especially during the pollinating period, can actually kill off the pollen of some plants, particularly maize, reducing final yields. Even though the plant in and of itself may look fine, high temperatures can actually be a killer in some cases, reducing yields. As we can see here in this particular case, we're looking at the current season in the blue line, and you can actually compare it to the 5-year min and max over time. As you can see, generally early in the season, we start below the average, which is good, and then as we get into the main growing season, we're right on par, right in between the min and max, showing relatively average conditions. And then as we hit senescence, right when that key period for pollen and yield development, we're seeing average temperatures, which is a good thing. And then as we continue throughout the final end of the season and harvest, temperatures continue to remain average. Okay, next slide, please. Okay, now taking all three of these in together is important in order to get a better understanding of how the season went. In this case, we can see a wet start to the season followed by a moderately dry period during the main vegetative period. However, if you look at the NDVI, we're seeing above average NDVI values, which indicates a healthy plant during the early part of the season and also during the main part of the growing season between green up and senescence, and then normal after that as we get into harvest. And then if you look at the heat stress days, we're looking at average conditions throughout the main part of the growing season and during that critical period I mentioned earlier. And overall, despite the reduced rainfall during the main vegetative period, we can see that the heavy rain and the higher values of the rain early in the season, more than likely than not, help keep soil moisture levels high enough during the main growing period to keep the plant healthy. So overall, in this particular case, for the upper west region of Ghana, we're seeing overall yields this year were actually above the 10-year average. And so this right here is a really good year and is supported by these indicators. Okay, next slide, please. Kiersten?
Sorry, thanks. Okay, so how the indicators will be calculated. I'm sure that people might be a little nervous that they might have to calculate them themselves, but never fear. USAID and Feed the Future are currently building our capacity to use remotely sensed data that inform these indicators, but we don't yet have that capacity on board. We are currently being supported in these efforts, again, by the NASA Harvest Consortium, as well as our colleagues at Food for Peace and FuseNet. So we'll have that support. Implementing partners will not need to calculate these context indicators. Basically, all you have to know how to do is learn how to interpret our performance indicators, and specifically yield, in the context of these indicators of rainfall, temperature, and greenness. I think another thing that we should say here is that this is an introductory webinar, so you know, for those who aren't very familiar with these context indicators, this is the first opportunity to learn about them. I think that going forward, we can have additional webinars that focus on actually that interpretation. But that should be your main focus. Don't worry about calculating. Just learn how to think through what kind of results are you seeing, and how can the weather's the performance of the weather help to explain the yield-related outcomes that you're seeing on the ground. Go ahead.
Thank you. All right, now we just saw a pretty good year, above average year. Now, looking at the different things, each year can look a little different. On the case here, we have the same region in Ghana, the upper west region, and now we're looking on the left as a below average year, the middle an average year, and the right an above average year. On the left, we have a below average year where we're seeing moderately dry, moving to extremely dry conditions at the start of the year in the precipitation graph on the top. And then as combined with a high number of heat stress days, as you can see at the bottom, maxing out there. And then you can see as the NDVI has slowly gone down and actually gone quite below. Now, in the middle graph, we see an average year. Here, the rainfall was moderately wet and then normal through the main part of the crop development. And then combined with a low number of heat stress days, the NDVI remained pretty much on the normal line, fluctuating a little bit here and there, which produced an average yield that year. And then on the right, this is the same example we just saw earlier of an above average year where the rainfall early on really helped to get the crop growing, and then the heat stress days remained low enough that did not affect the final yield in this case. And so this ended up being an above average year. Just as some examples, going through these, what you might see on the ground with these charts, you can see here on the left some maize where we did have a not so good year, and particularly due to dry conditions. And then on an average year, the maize will look actually quite healthy. As you can see, the crop is doing quite well. And then in this particular case, on an above average year, we see the crop quite healthy, quite nice and tall, and quite doing really strong growth, which also led to quite strong yields. All right, in this case, we're looking at Senegal and rice as a difference instead of just maize. All right, in this case, we have a below average year on the left, an average year, and an above average year. As you can see on the left, with this year, we have quite a bit of drop in rainfall. And for rice, rainfall is quite a huge impact. Without it, the crop will simply not do well. And then if you look at the average year, the rainfall was sort of hit or miss, up and down, but it was still enough at that point to create an average year. And then with the above average year, we're seeing quite a bit of rainfall, above the normal, but that also helped push the crop into a good yield. If you look down at the heat stress days, as you can see across the three different years, that the heat stress remains relatively the same. And so in this case, heat stress in Senegal, the central region, for rice is not a huge impact because it remains so consistent over time. So that's something to keep in mind, that in some regions you will not see certain indicators being a huge factor in the final yields. All right, and here's some more pictures, just as an example of things on the ground. You can see here in this case for rice, conditions were a little bit drier and the crop didn't produce quite as good yields. I see we have a question on the side about how heat stress days are calculated. Ritvik, I was wondering if you would like to take that.
Sure, Brian, thanks. Hi, everyone. This is Ritvik. In terms of calculating the heat stress days, we look at whether or not the average temperature of a day exceeds 30 degrees centigrade, and if it does, we take that to indicate that our threshold has been exceeded, and then we count the number of days for which the temperature exceeded 30 degrees centigrade. So in the graphics, you can see the blue line, which indicates the present year. It starts from 0, right? First day, the value is 0, but as you encounter more and more days above 30 degrees, the counting increases. And what you need to be looking out for in these graphics is if your blue line increases way more than the gray band, which indicates the metric value in the previous years, that indicates you have more heat stress days as compared to the past. And yes, the temperature is the air temperature. It's I think 2 meters above ground surface. So what you need to be taking into consideration is how the blue line is progressing compared to the gray band, which indicates the previous years. Is it exceeding the gray band? Is it sort of in the middle of the gray band, which indicates you're about average as compared to the heat stress in the previous years? Or as Brian showed in the case of one of the cases where it was actually on the lower side of the gray band. Okay. Thanks, Brian.
Thank you very much, Ritvik. See, we also have another question regarding heat stress impact on rangelands, being less sensitive than crops. Unfortunately, my expertise is not in rangelands, so I'm not able to answer that. Ritvik, do you have any information on that?
Well, so one simple option could be we could change the threshold, right? And presumably rangelands are less sensitive to the heat stress day threshold that we have chosen, which is more agricultural specific. So that's something that could be potentially easy to do.
Thank you. Yeah, it's definitely something we follow up on later.
Yeah.
And I can also mention that the Severe project has a rangelands decision support tool that I think may incorporate some of these measures or similar remote sensing variables, and we'll put a link into that for further exploration.
Thank you very much. Okay, moving on. Looking at the average year, you can see the crops are doing decently well here, particularly in this paddy area. And then actually quite a good year, seeing quite decent yields. There we go. Now, if you want to do more of an examination over time, comparing year on, you're going to see, in this case, we're looking at actual yield information from our implementing partners in the field. They're looking at Ghana particularly. This is an average final yield over all the zones of influence in Ghana. Now, in Ghana, majority of the zones of influence happen to be in North Ghana. So in this case, we're looking at precipitation, NDVI, and heat stress days in northern Ghana. As you can see from the color graphs, we can track each year and see the differences in each year. Now, in this case, where we have very minor fluctuations in yield, it can be a little tough to suss out what might be the individual cause of why those yields might be there. I mean, if you look at the graph, we can see that particularly in 2015, there was a dry start to the year. Now, a good question with that, which you might want to be asking on-the-ground people, was with a late start in the rain and such dry conditions early on, was there a later planting and that would allow the yields to catch up, or how did it go? Also, if you look at 2017, we'll see the heat stress days are quite peaked just right at that key time period when the crop is developing its pollen and seeds. So that's something to be aware of. But in this case, we find that a lot of times the more you disaggregate the information, the better it is. You can actually get down to the individual variations in regional temperatures, precipitation, and NDVI. Okay. All right. Thank you, Kiersten.
Okay. So, kind of in closing, we just wanted to think through what, in addition to yields, what other trends we might also better understand in light of rainfall, temperature, and NDVI. So as I mentioned before, if there's no rain, for example, farmers might decide not to invest in improved seeds, or they might not buy as much fertilizer. They also might reduce the area that they plant for that season because they expect more losses. So again, while our initial focus, as we're just starting to work with these kind of contextual variables, our initial focus is to try to interpret yield levels and trends. We're also currently in the process of looking at whether there are data available within Feed the Future from implementing partners or possibly part of the zone of influence surveys that would allow us to look at some of these other outcomes that we're interested in light of rainfall, temperature, and DVI. Implementing partners may be interested to assess their own data on input use and area under cultivation using these contextual variables. And again, if available data allow, we will try to organize a future webinar that will go into more depth on this particular topic. And so I think we can go into questions and answers now.
Yeah,
we have a couple.
That sounds great. And we do encourage you, those of you who have joined, to ask questions. Really, there are complexities to this topic, and there's really no question that's too simple or too complex. This is a great chance to get your questions answered live about these indicators, and even to share perhaps a specific example from your field project and ask for some advice about it. Let's see, we answered a few questions already in the chat box. We've had a few more come in. Let's see. So a question just came in from Andrew, who asked, can we use this information or approach to give an estimate on the likelihood of successful harvest based on historical rainfall? We see increasing cropping of highly marginal areas. Of course, it depends upon crop. Perhaps you could even be advising on different crops and likelihood of obtaining a successful harvest. Any comments on that?
Well, if I may, so this is Ritvik. This could be used as an input to looking at, let's say, pre-harvest yield losses, and that's something that's ongoing work over here at the University of Maryland. For now, as Brian showed, that it's also possible to get a quick sort of a qualitative overview of what you expect the yields might be depending upon how these time series have progressed over the season. So this is a more qualitative approach, and we have a more sort of quantitative machine learning based approach in the works that will work for these countries.
Great, thank you. Let's see, a question came in from Kathy Peary. Are there plans to share this type of information or data with financial institutions and or crop insurance companies, which might help them initiate insurance payouts for farmers with lower yields?
So I think for these particular indicators, they are too kind kind of too broad. We're really looking more at the zone of influence level rather than for individual farmers at this stage. I do know that there are some companies that do sort of register individual farmers, profile them, and then provide imagery of their fields. And then if they do need to request a payout from an insurance provider, that is something that they can use. But these particular indicators, it's too rough to be able to do that kind of analysis. But that's a good question. Thank you.
Great, thanks, Kirsten. And then Mark Doyle asked, what is the resolution of the data collected? Is it sub-hectare?
So the data sets all have different resolutions. The temperature and precipitation data sets are half degree, so that's like 50 to 55 kilometers. The CHIRPS data set is, if I remember correctly, 1 kilometer, I think. Brian, correct me if I'm wrong. And the NDVI data set, the original data set is usually like 250 meters to 500 meter resolution, but we aggregate it up to about 5 kilometers. And the rationale is that some of these, for example, temperature in generally non-topographically limited areas, you don't expect temperature to change very dramatically. And we're looking at fairly broad regions, so zone of influence level. So there is not a whole lot of fine-grained variability for these data sets.
Great, thank you. And another question had come in from Mark Doyle. You mentioned maize and rice. What other crops can be distinguished through this platform, such as sorghum or millet?
That's a great question. Technically, the plots are can be made for any crop. All we need to do is feed in the right crop mask, which will tell us which location of the country a particular crop is being grown in, and then we can extract the signals for NDVI, for temperature, for precipitation, which is used to compute SPI, and then we can make these graphics. And then we can also adjust our threshold. So for example, the number of heat stress days, threshold of 30 degrees, we can adjust that and make it really crop specific. So it can be applied to multiple crops.
I would add one thing, that having the crop-specific calendar is quite helpful. So you're better able to interpret what different things mean during the particular critical growing periods for each crop.
Mm-hmm.
Excellent, thank you. And then another question from Kofi Henaku. I assume the primary data used for the analysis is mainly satellite. Is there any intention or an already existing program to develop a network of local data collection?
With the CHIRPS data, I would mention that it does include station data from around the world. So there are some on-station data collection for the precipitation data.
Yep, I just exactly to that point, Brian. I put the blog that the Climate Hazard Center put together on blending CHIRPS data and the weather station, the locally collected weather station information. To that point, I put the link into the chat box.
Great. Well, I think that was all of the questions that have come in so far. We still have some time. We'll certainly wrap this webinar up a little earlier than the calendar invite had stated. We wanted to allow plenty of time in case there were a great deal of questions. But we do still have a few more minutes. If anyone has any questions at all that you would like to ask, or if there's a particular slide you'd like to return to for some further clarification, we are happy to do so. Kirsten, I thought you might also have a question or two more generally that you might like to ask our attendees who are on the line today. We had talked about, potentially asking them for some of their perspective.
Sure. I mean, it's a little bit hard to do it one way, but if it's possible for people to respond in the chat box, it'd be great. I mean, because this is new, and we don't have a good sense of how familiar people are with this kind of information. Are you guys excited to use it? Do you think it will help you understand the results of your work better? Are you already using information like this to interpret your results, and it's just something that USAID doesn't necessarily see that implementing partners are doing on their own? Very happy to see Kathy. Kathy's extremely excited to use it. That's great to hear. Is Andrew Bisson on the line at all? I saw Andrew, but I wasn't sure if it was Andrew Bisson. Jesus de los Santos is asking if it's possible to use this information to assess productivity. Oh, Andrew's there. Andrew, well, can you go ahead and respond to Jesus? I think we've had some conversations that I think it suggests that it would be possible, at least to use NDVI as a kind of proxy for how well cows are doing in terms of access to forage.
And Andrew, if you'd like to respond verbally, I can give you the call-in number to have your voice come through. I'll go ahead and post that in a private chat for you, but you're also welcome to use the chat box to answer. I'll start a private chat with Andrew and send him the call-in just in case he'd like to call in.
And so Kathy's curious to know whether this is being connected with USAID's climate links activities. So this, as Julie mentioned earlier, this whole month we've been doing a monthly theme on AgriLinks called Earth Observations for Food Security and Ag. And we've been coordinating a bit with our climate links colleagues, but I think it's a good idea. I'll shoot them an email afterwards to let them know about this webinar and see if they'd be interested in posting the slide deck or possibly the recording afterwards, because I think you're right, it would be relevant to their work. The other thing, while Andrew's responding, that we can mention is that later this afternoon we have another webinar. The Climate Hazard Center, which actually produces the CHIRPS data that we referred to, they will be, there's a webinar that they're presenting that people who are interested in this area might like to attend. That starts at 1 o'clock Eastern time. All right. So let's see. And yeah, just to reiterate Julie's earlier point, we've got lots of kind of related posts that have been added over the past month to the AgriLinks site that people might be interested in checking out if you find this information useful.
Great. Yeah, and thanks, Carrie, for the advice that some of the organizations working in climate information services would find this information valuable. We certainly will share this recording far and wide and the results of the Earth Observation Month as far as we can. And also, everyone, I posted the link in the chat box just now of where the webinar recording will be posted later today. If you would like to share the recording with your colleagues, it will be available on AgriLinks on the same event page that kind of housed the information about this webinar.
So it looks like we got a response from Andrew. So in response to the question about whether this information can be used to look at livestock-related concerns. So he says it depends on how the cows are being fed, and if they're dependent on rain-fed forage, then the greenness of the available pasture is important. And I think you'll be, you may be able to see that in the Rangelands decision support tool that we linked to earlier. However, dairy cows would generally be fed grain supplement plus potentially additional fodder. So a dairy farmer would adjust the feed purchases to maintain cow nutrition and therefore dairy productivity. And then, of course, this becomes an economic decision. So if conditions are poor and fodder prices are high, then purchases would fall, as would milk yield. In summary, it's not an easy question to answer, as it's a tricky correlation, and it might be most useful to predict fodder prices. There you go.
Very interesting.
I think for me, it opens a whole new way of looking at our work, at the data that we collect, and this kind of information can give us insights from everything, I think, as others have pointed out, from design, like where are the best places to plant crops if these are the prevailing weather conditions. For our monitoring and evaluation, I think it's really a good direction to be moving in, and I really I want to thank again NASA Harvest, our colleagues at NASA Harvest, for all of their help and support in building our capacity to work with these data.
Great. Well, I think it seems that we've answered all the questions that have come in and covered our topic for today. So I think it makes sense to wrap up. I put out a last call for questions, but I haven't seen anything come in, so I think we might be good to go. I see a few people typing. We'll see over the next minute or so if something else comes in. I've reposted the links to the previous installments in the Feed the Future MEL webinar series if anyone would like to review past content. And again, we'll post the recording here or on AgriLinks later today and make sure that it's shared far and wide so that you can share it with your colleagues or review the information as necessary. So I'll say thank you very much to everyone for joining, and a special thank you to Kiersten, Brian, and Ritvik for your very interesting and thorough presentations. And we will be in touch about using these indicators going forward.
Thanks so much, Julie.
Sure. Thank you all. Have a good rest of the day.
Thank you, guys. Bye-bye.
Bye.